Ever wondered how developers handle errors and exceptional situations in a program? Well, that's where exception handling comes into play. Exception handling is a programming construct that provides a safety net for code, catching those pesky runtime anomalies that can occur during a program's execution. Think of exceptions as the unexpected guests at your program's party. They're like the division by zero errors, the file not found alerts, or even attempts to access an array index that's out of bounds. Not fun, right? But just as a good party host knows how to handle unexpected guests, a good developer knows how to handle exceptions. By managing these exceptions, developers can ensure their code is robust and fault-tolerant, capable of withstanding those unexpected bumps in the road. So, remember, just as a good driver knows how to handle unexpected road conditions, a good developer knows how to handle exceptions. Imagine a safety net under a trapeze artist. That's what try-catch blocks are in programming. In the daring world of programming, we frequently walk a tightrope, balancing the need for functionality with the risk of error. And in this high-wire act, try-catch blocks serve as our safety net, catching exceptions that might otherwise send our code plummeting into the abyss of runtime errors. Picture the try block as a daring acrobat, performing a high-risk maneuver. This is the section of our code where we suspect an exception might occur. It's a potentially dangerous act, but one that must be performed. We surround this risky code with a try block, effectively putting our acrobat in the air, ready for the performance. Now, what happens if our acrobat slips? That's where the catch block comes into play. Just like a safety net, it's there to catch any exceptions that occur within the try block. Each catch block is designed to handle a specific type of exception. For instance, if our acrobat loses balance, we might have a catch block specifically designed to handle that scenario. In programming terms, if the code within our try block attempts to divide by zero, we might have a catch block designed to handle arithmetic exception. But what if something else goes wrong? What if it's not a loss of balance, but a sudden gust of wind that sends our acrobat off course? In programming, this could be an array index out of bounds exception or a null pointer exception. For each type of exception that our code might throw, we can design a specific catch block to handle it. And just as a trapeze show might have multiple safety nets for different types of falls, our code can have multiple catch blocks, each one tailored to catch and handle a different type of exception. The key is to arrange these catch blocks from the most specific to the most general, so that the most appropriate catch block handles each exception. So next time you're coding, remember the trapeze artist and the safety net. Use try-catch blocks to perform the daring feats of coding, knowing that if something goes wrong, your safety net is there to catch the fall. In the world of programming, try-catch blocks are your safety net. Sometimes you need to be the one to say, hey, something's not right here. That's when you throw an exception. Let's talk about throwing exceptions. In the world of programming, throwing an exception is like sounding an alarm. It's how we alert the system that something has gone awry, something that we didn't quite anticipate. Now, how do we throw this alarm? We use the throw statement. It's a pretty straightforward command. You simply type throw, followed by the exception you want to signal. This could be a standard library exception, or a custom one that you've crafted to suit your specific needs. But what exactly are these exceptions we're throwing? Well, they're instances of exception classes. These classes are like profiles of the different types of mishaps that might occur. They provide essential information about what went wrong, where it went wrong, and sometimes even why it went wrong. But here's the thing. Throwing an exception isn't just about sounding the alarm. It's about ensuring that the issue is handled appropriately. You're essentially passing the buck to the next suitable handler in the chain. And if no one catches your thrown exception, well, it'll keep on propagating up the call stack, potentially causing the whole program to terminate. Throwing exceptions is like raising a red flag to highlight a problem. It's about acknowledging that something's gone wrong and signaling for help to fix it. It's an integral part of writing robust, reliable code. In the world of exceptions, not all exceptions are created equal. Delving into the realm of exception classes, we find that these classes provide a wealth of information about the nature of the exception that has occurred. A standard library, for instance, often features a hierarchy of exception classes that developers can tap into or even extend to create custom exceptions. These classes are arranged in a tree-like structure, with a general exception class sitting at the top and more specific exception classes branching off. This arrangement is no accident. It's designed to give you, the developer, the power to catch exceptions at various levels of specificity. You can catch an exception at a lower level to handle a specific situation, or at a higher level to deal with a group of related exceptions. Now, imagine you've created your own custom exception class, perhaps to handle a unique error in your program. This custom class can inherit from one of the standard exception classes, allowing it to carry over certain characteristics, while also adding its own unique details. This ability to extend standard exception classes provides a great deal of flexibility when handling errors. But what happens when an exception is thrown and not caught? This is where the concept of exception propagation comes into play. If an exception is not caught in a particular block of code, it doesn't just vanish into thin air. Instead, it propagates or climbs up to the enclosing blocks. This can be visualized as an exception knocking on the doors of successive code blocks, asking if they can handle it. If not, it moves on to the next block. This process continues until the exception either finds a catch block that can handle it, or reaches the top-level block. And if it reaches the top without being caught, it can result in the termination of the program. So it's essential to ensure that exceptions are properly caught and handled. This not only prevents program termination, but also aids in debugging by providing valuable information about the error. Remember, uncaught exceptions can climb up the code hierarchy, potentially causing a program to terminate. Exception handling, when done right, can make your program robust and fault-tolerant, contributing to its reliability and maintainability. Knowing how to handle exceptions is good. Knowing how to handle them well is great. Let's delve into the best practices for managing exceptions. And trust me, these tips can be the difference between a program that crashes and burns and one that runs smoothly, regardless of the hurdles it encounters. First off, when catching exceptions, be specific. A generic catch-all block might seem like an easy way out, but it's not the best approach. When you catch specific exceptions, you're able to handle each type of error in the most appropriate way. It's like knowing exactly what kind of bug you're dealing with, so you can squish it effectively. Next, let's talk about the size of your try blocks. Remember, size matters. Keep your try blocks petite. The smaller the block, the easier it is to pinpoint where an exception might occur. It's like looking for a needle in a haystack. The smaller the haystack, the easier it is to find the needle. Now, onto the finally block. This block is like your safety net, there to catch and clean up any leftover mess regardless of whether an exception occurs or not. Use the finally block to ensure that resources are properly released. It's like tidying up after a party. No matter how wild things got, you want to make sure everything is clean and in order afterwards. Logging is another essential practice. Use logging mechanisms to record information about exceptions. It's like your personal detective, keeping track of all the clues and evidence, helping you to solve the mystery of why your program isn't running as expected. Lastly, but certainly not least, avoid swallowing exceptions. This might sound strange, but bear with me. Catching exceptions without proper handling can lead to silent errors, and trust me, those are the worst. It's like ignoring a warning light on your car dashboard. Sure, you can keep driving, but sooner or later you'll wish you'd dealt with it sooner. So there you have it, some of the best practices for handling exceptions. Remember, exception handling isn't just about preventing your program from crashing. It's about ensuring your program can navigate and recover from unexpected situations. It's about resilience. And who doesn't want their program to be resilient? Exception handling is more than a safety measure. It's an art, and like any art, it requires practice and refinement. So we've taken a journey into the world of exception handling. We've explored the try-catch blocks, which are the first line of defense against runtime anomalies. We've learned how to throw exceptions, both standard and custom, to signal that something out of the ordinary has happened. We've delved into the realm of exception classes and propagation, understanding the information they provide and how they move through our code. And we've shared some best practices, like catching specific exceptions, keeping try blocks small, using finally for cleanup, logging exceptions, and not swallowing them silently. All these elements work together to make our software robust and maintainable. Remember, exception handling isn't just about catching errors, it's about managing them in a way that our program can survive and function gracefully. Exception handling might seem daunting, but with understanding and practice, it becomes a powerful tool in your programming toolkit.